Hello, I'm N J Wildberger. We're here at the University of New South Wales. This is Chapter 5 of the Linear Algebra 1131. And in this problem, we are looking at a rather abstract problem involving arithmetic with n by n matrices. So the question is, let A and B be n by n matrices with A squared equals the identity, B squared equals the identity, and AB all squared is the identity. Then we are to prove that AB equals BA. So I remind you that in general, when we're working with matrix arithmetic, matrix multiplication is associative. This is a key point. But matrix multiplication is not generally commutative. So in general, AB does not equal BA. It's rather special when two matrices commute like this. So that's the content of the question, that these three conditions are strong enough to force commutativity between the two matrices A and B. Because it's a very general question, we're just talking about n by n matrices, we don't really have a hope of using coordinates. We just want to work at the level of general arithmetic. All right. So here's our solution. What are we going to do? We have to use these three pieces of information. So let's start by suppose that A and B are n by n matrices satisfying A squared equals the identity, B squared equals the identity, and AB squared equals the identity. So in an exam, you probably wouldn't write this statement, but here I'm just making sure that we are all on the same page. We know exactly what assumptions we are invoking. Okay, so these are the things that we have to work with. So what are we going to do? Well, this is the most interesting of the three relations. So let's have a look at more carefully what it actually means. All right, so what does it mean? Well, AB squared means AB times AB equals the identity. And since matrix multiplication is associative, we can rewrite this, in fact, without the brackets. The brackets are not really necessary. So we will write it as AB equals the identity. All right, what can we do with this relation? We want to use the fact that A squared equals the identity and that B squared equals the identity. All right, so we're going to do a little bit of a trick. We're going to multiply this equation by A on the left and by B on the right. The idea is that then we'll get an A squared on the left part of the expression, which will be the identity, and we'll get a B squared on the right part of the expression, which will be the identity, and so that will simplify. All right, so we'll write that A times AB times B equals A times B. All right, so we've just taken this expression and multiplied it on the left by A and on the right by B, using the fact that the identity times anything is that anything. So when we multiply I by A, we just get A. And maybe we'll carry on. So this is true. And so A squared times BA times B squared equals AB. So I'm just rearranging by associativity, grouping the two A's together here and the two B's together here. But then A squared is the identity, B squared is the identity, so we have the identity times BA times the identity equals AB, or AB equals BA. So we've arrived at the required result, and we've made sure to use all three pieces of information That's generally a guide to how to solve some more abstract problem like this. You're given 3 pieces of information. Try to make sure that you use them all during the course of your proof.